Hit record. All right.
Perfect.
Number 13.
Yeah, we got some numbers.
Yeah.
We finished number 12.
I'm not sure we got to the domain on number 12 or 11.
Or I don't think we did no, we didn't do a number 11 or
We
12
talked
actually.
about the domains on maybe 5, 6, and 7. The most important thing to remember about domain with composite functions is use the restrictions for everything. In other words, look at the domain of f of x, look at the domain of g of x, and then look at the domain of f of g of x.
Okay.
And if there are multiple restrictions from the different functions, use all of that in your domain restrictions.
Okay.
We had one that was like that, where the final composite function only appeared to restrict, x couldn't be 8, but one of the original functions, x couldn't be 0. So it carries forth. Even though the final answer was 1 over x minus 8, x still could not be 0. So that's the thing to keep in mind with domains.
Okay.
Always use the most restrictive ones.
Okay.
All right. Now, how do you verify the two functions are inverses of one another?
Okay, number 13. So we would do, y is, or x is, yeah, no, x.
Oh, this is so frustrating to have to deal with this. I can't believe Windows has it like.
Oh, yeah, I don't like the new update. Yeah, so we would do x is equal to 2y minus 3.
Well, I don't need to rewrite the functions since they're written right there. What rule has to be true for two functions to be inverses of one another?
The opposite.
No, it's this. F of g of x has to be equal to x.
Okay.
And g of f of x also has to be equal to x.
Okay.
And I'm not sure that you need to prove both every time. I've never seen a function where one was equal to x and the other one was not.
Right.
Now, another way I can write this is f of its inverse is always equal to x.
Okay.
Right? So that's what we're going to do on 13 in order to prove that one is an inverse of the other. You still there? I heard a beep.
Oh, yep, I'm still here.
Still got the audio? Okay, sometimes that beep signals a loss of audio. So
weird.
let's see what f of g of x is.
Okay.
What's the first thing I should write? F of what?
So we would do 1/2 x plus 3/2. Okay.
And now what is that equal to?
And then that would be equal to, let's see.
Look at the f function.
Would be 2x minus 3.
No? Remember this.
Yeah.
Here's the f function. This is a key point in math. You really need to get this.
Okay.
I think you know this, but if I said, what is f of 4, what would you do? How would you figure it out?
You would plug in 4 where x is.
Okay. So what is f of 1/2 x plus 3/2? Remember I said that no matter how complicated it is inside the parentheses, that's what you plug in.
Okay, so we would do f of 1/2 times 2x minus 3 plus 3/2.
Here's what I'm going to do. I'm going to go to this function, And
Right.
whenever I run into x, I'm going to substitute what's inside this parentheses down here.
Okay.
So
So,
it becomes 2 times, with me?
yep, I'm still here.
Line through, no, I mean in understanding. Are you with
Oh, I think so. Yeah, it's
me? In other words, just because it's a complicated thing over here on the left doesn't mean it's harder to do. It's very simple. It's very straightforward.
okay.
Whatever is in these parentheses goes in wherever you see x on the right side of the function.
Okay.
Notice that that's what is going on between those two. Is all
Mhm.
I've done is where I saw x, I plugged in this.
1/2 x plus 3.
Now, now let's see if this is equal to x. Remember, that's the rule. It has to be equal to x for it to be an inverse of one another.
Uh-huh.
So let's do the algebra, simplify that.
All right. So would you just FOIL it?
No, one
No.
term by two terms. No need for a FOIL. Simplify that expression. First thing is always get rid of the parentheses. If you don't know where to begin, get rid of parentheses or denominators or exponents.
All right.
Well, we've got some denominators here, but if I get rid of the parentheses, those denominators will each disappear. So I want to
Okay.
get rid of the parentheses first.
Um,
How do I do it?
would you, um,
Distribute the 2.
so 2 times 1/2
Uh-huh.
x.
What's 2?
Okay.
What's 2 times 1/2?
Um, 2 over 1 times 1/2 would be 2 over 2. Or no, you add it, well, no. So 2 over 1 times 1/2, yeah, it would be 2 over 2.
Which is?
1.
Okay. Now, I'm not sure why you do that. In other words, let's talk about this, because I hate to see it slow you down so much.
Yeah.
The only way you seem to be able to do this is if you put a 1 under there, and then you multiply numerators and denominators. That's a lot of steps.
Yeah.
Okay? Why not leave, don't put the 1, and just always know that that is multiplying the numerator
Okay.
only.
Yeah.
I can immediately go to that step there. And in fact, if I want to simplify this first, I'll cross that 2 out with that 2, replacing them with 1s each. Then it's immediately 1.
Right.
Okay?
All right.
And this may seem subtle points, but I think it's important. It's going to affect your speed.
Yeah, for sure.
Constantly slows you down.
Uh-huh.
And when you take time tests, that's definitely going to affect you. So,
Yeah.
so the first one is just x.
Uh-huh.
What's 2 times 3/2?
And then that would be 6 over 2, which is 3.
Okay. And then minus 3.
Uh-huh.
So the 3's cancel. It's equal to x. That means g of x is an inverse of f of x.
Okay.
Okay?
All right.
And we could do the other one just for practice. Let's make sure that g, well, I don't know. You probably want to get through these.
Yeah.
Let's do that then. Let's go to 14.
Yeah, let's do that.
Is all we really, unless your teacher makes you do otherwise. Your teacher on a test may make you figure out f of g of x and also g of f of x. Make sure they're both come out to be x. It's a lot of algebra, but that's all it is algebra.
Okay.
So this time, I'm going to write the f of x. And
Uh-huh.
for some reason, I think that's going to help you.
Yeah.
Even though it's written over there, but
Mm-hmm.
all right.
All right.
So what's the first way I should write it? I'm trying to figure out f of g of x. See whether that's
So,
x or not.
are we doing number, which one are we doing?
14.
14. Okay. Alright, just making sure. So, how do you know, like, if you're trying to find, like, f of g of x or g of
Do
f
it
of
one
x?
step at a time. They're different. In other
Yeah.
words, this is clearly f of g of x. The first letter is the outside, the inside is g of x.
For
Inside of
14.
parentheses. Yeah. Notice, remember what the definition of inverse is.
Uh-huh.
Both have to be true. F of g of x has to be x, and g of f of x has to be x. So we'll just always do f of g of x.
Gotcha, okay.
Okay?
Alright.
How
Alright.
do I do this problem? What's the next thing I have to write?
So it'd be f of x cubed minus 1.
Okay? And then what is that equal to?
And then that is equal to, um, let's see here. This would, for this one, it would be
Mm-hmm.
parentheses, x to the third, no,
Yep.
parentheses x plus third.
No, don't try to do two steps in one. You're getting confused by this plus one up here.
Yeah.
Here's what we're doing. We're plugging this in only whenever we see an x.
Gotcha.
And plug it in as a parentheses. In other words, let's use a double parentheses here.
Alright.
And it makes it less confusing.
Yeah.
So I plugged it in for x, and I still have that plus 1.
Oh.
In other words, you don't do anything but carry that forward. And
Okay.
I'm taking the whole thing to the 1/3 power.
Uh-huh.
So that, and now I have to simplify this. So what's the first thing I got to do to simplify it?
Get rid of the parentheses.
Which one?
The right one, x to the third.
No, actually, always going to work from the inside out.
Okay.
In other words, we want to get rid of the parentheses that I put around the x cubed minus 1.
Okay.
Those parentheses weren't really necessary.
No.
So I can just erase them. It doesn't change anything. The only reason I put them there was for clarification so that you could see exactly what I'm doing here. And all of these problems are exactly the same. You just take whatever's inside this parentheses and plug it in wherever you see x. Straight as that. Well, I can just erase those. Now, you want to get rid of the outside parentheses, but it's a lot easier if we get rid of this minus 1 plus 1.
Which is 0.
0. So this becomes x cubed to the 1/3 power. What's that equal to?
So it would be 3. Or, yeah,
No.
3 over 3, which is 1.
No. Well, okay, but the answer is x to the 3 over 3.
Yeah. Just x, yeah.
Which is just x.
Mm-hmm.
Again, those two functions are inverses of one another.
Okay.
Okay, let's see, where's 15? 15.
Yeah.
Find the inverse function. Now these are actually a little easier because there's only two rules when you're finding an inverse function. You know what they are?
Just do the opposite of what it shows.
Well, it's more than
basically. It's more.
Well, there's actually three rules. First of all, you turn the f of x into a y.
Right.
So I'm going to write the function like this.
Okay.
And first rule, switch the variables. Second rule, solve for y after you switch the variables. So what's y equal to?
So it would be y is equal to x plus 8. Oh yeah, we already, my bad. Yeah, so it would be x is equal to,
No, we're solving for y. Second rule is solve for y. First rule, switch the variables. Second rule, solve for y.
okay, so it'd be y is equal to x minus 8.
That's its inverse.
Cool.
There's your inverse. That's why I
Sweet.
say it's much easier to find an inverse because there's only two rules.
Uh-huh.
It's actually
Right.
three because the first rule is you really need to substitute y for f of x.
Okay.
I mean, I guess you wouldn't have to. You could use f of x, and
Mm-hmm.
second rule would then be solve for f of x. But I've always found it's easier if you use the y notation instead of f of x.
Mm-hmm.
So what's the next line?
So the next line would be, x is equal to minus 2y plus 1.
And now what?
And then it'd be x minus 1 is equal to minus 2y.
And,
And then it would be, you divide by minus 2 on both sides.
okay, so
So that would be,
get rid of that.
yeah.
So that's the function.
Uh-huh.
And that probably, you wouldn't lose points on that. I'm
I
not
think that'd be,
sure that this should be changed, but it so happens that that thing can be maybe simplified into 1 minus x over a positive 2. This
yeah.
is the same as that.
Uh-huh.
Whether you have to do it or not, probably not. I don't think any teacher would take points off. I'm not even sure it's called for to change it.
Yeah, I don't think so.
There you go. In other words, once you've solved for y after switching the variables, then
Mm-hmm.
that's your inverse function. Now, you can actually do those two steps in reverse, but I would always do it the same way.
Okay.
In other words, you could solve for x and then switch the variables,
Uh-huh.
but that's just confusing to have two different ways to do it. Always do it exactly the same
Okay.
way. Okay. Let's see, there's a 17 over here.
Yep.
So what should I write? Tell me everything to write.
Okay. So this one would be y is equal to 2x to the fourth to start out. And then x is less than or equal to 0. And then it would be x is equal to 2y to the fourth. Y is less than or equal to 0. Um,
Well, let's set that aside for a moment. I don't know that you have to write that at every step. I wouldn't write that. I'll explain after we come up with the answer.
oh, okay. All right. And then now we would divide by 2 on both sides. So that'd be 1 half x is equal to y to the fourth.
Okay? Or you can write it like that.
Okay.
Now what? Solve for y.
And then we would square root it. Or,
Not square rooted. If I square rooted it, I'd be solving for y squared.
right. Or what would that be?
Fourth,
Like
fourth.
fourth root, yeah. Is that what okay.
Yeah, I can either write it using the radical sign, but
Uh-huh.
at some point you don't do that anymore.
Mm-hmm.
That's the same thing. If I take it to the fourth root,
Okay.
I mean, put it this way, I've never seen this written like that, the eighth root written like that. I
Okay.
write square roots using a radical sign, and even cube roots you write with a radical sign. But
Uh-huh.
as the root goes up, you tend to always write it as a fractional x bar.
Okay.
Uh,
Okay.
And that does, now there is a caveat here.
Mm-hmm.
I've said to you in the past that whenever you are solving an equation by taking the square root of both sides,
Mm-hmm.
always begin your answer with the words plus or minus.
Okay.
In other words, if I have the following, if I have x squared equals 4 and I say solve that,
Mm-hmm.
I'm taking the square root of both sides, so it's plus or minus 2. is the answer.
Gotcha.
Okay?
Okay.
That applies whenever the power is an even number.
Mm-hmm.
So when I take the fourth root of the right side, I get y. But when I take the fourth root of the left side, I actually get plus or minus.
Okay.
Which takes us back to this original restriction they put on it.
Mm-hmm.
X is negative. X
Right.
is less than or equal to 0, so the answer is the minus.
Okay. So okay.
Final,
Well, so to get
the final answer should look like this, I think. I may have to think about this for a moment. I'm pretty sure it's correct.
Alright. I'm just confused. Like, how did you get x squared is equal to 4? Like, would you just simplify?
No, I was just using this as an example.
Oh, that's just an example. Okay, that doesn't have anything
This
to do
doesn't
with
have
it.
anything to do with this problem.
Okay, I was just kind of confused. Like, wait.
As to when you take the even root
Uh-huh.
number, your answer always begins with plus or minus.
Okay.
If you take the odd root of a number, it does not. In other
Right.
words, if I take the cube root of -8, I get just -2. If I
Right.
take the cube root of +8, I get just +2.
Mm-hmm.
But when I'm taking odd roots of numbers, it doesn't
Mm-hmm.
ever begin with plus or minus. It's either a plus or a minus. But if I'm taking even roots, always is a plus or minus. Well, in this problem, we're taking an even root.
Mm-hmm.
And the reason they put this restriction on it up here is they don't want a plus or minus answer. They want one or the other. And
Right.
if x is less than 0,
Mm-hmm.
it's negative,
Mm-hmm.
but we're taking a negative number to an even power, so it's the same as whether it's positive or negative. The question is, does it affect the inverse?
Right.
Hmm. And how can we figure it out? I guess I could apply the f of g test.
Uh-huh.
Let me think about it for a second. Let's see. If x is negative, they're talking about this x, first of all, not this one down here.
Mm-hmm.
Notice that we switched the variables.
Right.
So this was the original x, so it's really this that has to be negative.
Mm-hmm.
And since the fourth root is always going to be a positive number, x has to be positive here on the bottom right, and
Mm-hmm.
that's why we have to use the negative. So that
Gotcha.
indeed is the correct answer. That's a hard one. That's not easy to see, but I'm
Mm-hmm.
90% sure that that's the correct answer.
So that's the answer. It's just okay.
You don't have answers for these, do you?
No, unfortunately.
Okay.
Yeah.
18 is going to be easy because that's an odd power, notice. In other words, here we don't face that problem. And
No.
they didn't put the restriction on it either. Now I get it. You
Okay.
can't take the inverse of that without putting that restriction on it. Notice
Oh.
why. Let's stop for a second. This is important, and it's something I just kind of realized.
Okay.
If I take this function here, simple
Uh-huh.
parabola, right?
Right.
Well, inverses are always reflections about that line there. If I reflect that entire parabola about the line, I get this parabola.
Mm-hmm.
Problem with the bottom, the horizontal one, is it's not a function. Does not pass the vertical line test.
No.
So in order to even talk about an inverse with this function, I
Mm-hmm.
have to restrict it to positive. positive x's only. In other words, they were never going to ask you to find the inverse of this without restricting it. Only in our case, they're restricting it to negative x's only. So it's this part only that I'm going to reflect about that line, and that comes out to be the bottom half. That's the reflection, yeah. And so this is the inverse function right there of x squared. And we're facing almost that exact problem with number 17. Even though it's x to the fourth, it's still this problem. You got to restrict that original function to even be able to talk about an inverse. Whereas 18, it's not true. Because 18, you don't get that plus or minus effect.
Right. All right.
So next line.
All right. Yeah. So this would be x is equal to y to the fifth plus 6.
Next line.
And then it'd be x minus 6 is equal to y to the fifth.
And the last line.
And then we would multiply it by 1/5, right? On both sides?
Not multiply, exponentiate.
Oh, exponentiate by 1.
There's a big difference between multiplying by 1/5 like that or exponentiating by 1/5 like that.
Right. Okay.
Okay. Remember, we're trying to get it down to just y. If I multiply by 1/5, it would not turn into y. Whereas if I exponentiate by 1/5, it does turn into y. And do not have to put plus or minus here. The plus or minus doesn't. This is your inverse function.
Cool. And that's your answer. Cool.
Some inverse questions can really actually get quite tough, but I don't see any on here.
That one was easy.
Well, they get really tough if it's like a quadratic, and they say find the inverse of a quadratic.
Oh, wow.
Then there's some sophisticated math that it's hard to believe you can actually do. We got time for at least one more. Yeah?
Cool. All right.
This again, we're going to an even power, so they have to restrict the domain to positive x's only.
Gotcha. All right. So this one would be x is equal to 1/5 y to the fourth. And then it would be we would exponentiate both sides by 1/4. No, we have to. No, we have to.
Got to get rid of that 1/5.
Yeah, divide by 1/5.
Which is the same. Don't think of it as dividing by 1/5. Think of it as multiplying by 5.
Okay. Yeah. Just doing the opposite.
Sometimes this is going to be written like this. And when you see it written like this, you don't think of dividing by 1/5.
No.
Think of multiplying by 5.
Okay.
And I'd like to see you do it the same way every time. So even if that thing is a coefficient, I still want you to think of as multiplying by 5.
Okay. All right. Okay, cool.
And then what?
And then we would divide by 5. Oh, y to the fourth.
For y.
Yeah. So and then we would exponentiate by 1/4 on both sides.
Good.
Cool.
And this normally would be the plus or minus. You would need it because you're taking an even-powered root.
Right.
And you do need it here, the plus or minus. But now we have to decide that if x is positive only in the original function, then it's plus only in the inverse.
Okay.
In the last problem, x was less than 0, so we chose the negative answer.
Uh-huh.
But in this case, the answer is going to be without the negative sign, like that.
Okay, gotcha.
All right.
All right.
Dylan, I will let you go.
Sounds good.
Okay, buddy. Talk to you later.
All right, sounds good. Thank you, Mr. Cowan.
Bye-bye.
All right, bye-bye.